To solve the question, let us divide the charge capital Q in two parts. So writing that here, capital Q has been divided in two parts, small q and capital Q minus small q. Then these point charges are placed at a separation r apart, and we have to find the maximum value of the force of repulsion. So let's write the expression of the force. It would be K small q capital Q minus small q divided by r square. Agree? This in turn can be written as K by r square capital Q small q minus q square. Here the small q is a variable term. When we are taking the two parts of the charge, then we can take any value of small q. The remaining part will be capital Q minus small q. So if you compare it with y is equal to ax minus bx square, you'll come to know that if we plot the graph, it will be a parabola mouth opening downward. I hope you remember that whenever the coefficient of x square is negative, the graph is a parabola mouth opening downward. You can plot it very easily, x and y. X is equal to 0, the y is 0. You get this? X square coefficient negative, the graph will be parabola mouth opening downward. So if we compare it, this is a, this is x, here we have x square, and at the place of b we can consider 1. Means the force versus small q graph would be a parabola mouth opening downward. So plotting that here, on x-axis we take the variable term which is small q, on y-axis we take the dependent term which is the force F. When small q is 0, how much will be the force? 0, correct. Let's make a table here, small q and F. Taking small q 0, the F becomes 0. Taking small q as capital Q, what will be the value of F? If we put capital Q here, this is capital Q square, this will also be capital Q square, so this net term becomes 0, so the force is again 0. If we plot the graph, at the value of small q is equal to capital Q, the force is 0. When the small q is equal to 0, the force is again 0. It is clearly evident from this parabola mouth opening downward that we get the maximum value of the force when the value of small q is equal to, correct, q by 2, because parabola is highly symmetric figure. This distance and this distance should be equal. So when the small q is equal to capital Q by 2, then this charge will also be remaining as capital Q by 2. I hope you understood the answer. Now we can obtain the same answer using another way. This is the second method. We know the concept of maxima and minima. For maximum value of the repulsive force, the first differentiation of the force must be equal to 0. So let's do that here. Here K by R square is a constant. I am taking it outside of the differentiation, K by R square, and then differentiating the remaining terms, d by dq, q cube minus q square should be equal to 0. This K by R square we can send it to 0, then we are left with q d by dq of small q minus d by dq of q square. Agree? I hope you remember the differentiation. This becomes 1, so we are left with q into 1, and this differentiation is 2q. So the value of small q is simply capital Q by 2, shifting that to here. I hope you understood this answer again. So there are two intuitive methods of solving this question, and if someone asks us what is the maximum force, then we can easily obtain the answer. The maximum force will be K Q by 2 divided by R square, which is equal to K Q square upon 4R square. Here k is equal to 1 by 4 pi epsilon naught.